Hmm. Hi guys, how are you all? Yes, I would like to see you on the videos, guys. Hey, all of you have got your videos off. I will not even start the class. Okay, guys, let's move on. I don't know what happened to the others, but I'm going to move on, okay? So, any questions on the homework? It's absolutely fine to have the answers there, right? You had the images, right? Was it difficult?
Hmm?
Was it difficult for you to do the assignment?
You're breaking. Can you tell me again?
No, was it difficult to do the second assignment?
The second assignment.
Yeah,
I mean, it was.
yeah,
Take,
let it have answers, right? You're just going to take the picture,
it was
the diagrams you're going to solve and then check the answers, right?
diagrams. Oh yeah. Okay. Yeah.
Yeah. Meaning seeing the answer and not seeing is just our own mental makeup, right?
Mm.
Don't see the answers, just do the problems, then check. Make sense?
Sure.
Make sense, huh? Okay. Now, I want to ask Harshita and Johan, I saw your homework. I don't have any questions. Did you have any questions for me on the homework? Did you have any questions on the homework, Johan or Harshita? No? Okay. Shreya, how about you? Very nice, Johan. I heard that you are outside your house, but still attending. Very nice. I really liked it. Shreya, very nice, Amma. I saw your homework. Did you have any questions for me?
You ever think about where the twilight is in the Canterlot High School?
Amma, I'm not able to hear you. Is it me or you are speaking on mute?
I don't think I didn't have any questions.
Okay, Ma. Dhruv, how about you?
Do you ever think about the twilight? Like
Okay.
Canterlot.
He's not on the video still. Okay, let's move on. Because Dhruv, did you have any questions in the homework, Dhruv?
No.
Yeah, I'm just going to move on. I know I want you to be able to write proofs, but before we go write proofs, maybe I want to do transformations too. So my thought was I'll introduce you to a couple of proofs, okay? Simple proofs. Then what I do, I go ahead and do transformations because that is what is going to come. We have covered a good chunk during the summer. Okay, for you to get started at school, we have done a good chunk. That's my honest thought. So let's see. This is my plan. I will go ahead and do a couple of proofs, not everything, a couple of proofs. Then let me go ahead with starting transformations. We did reasoning, right? Meaning we did logical reasoning, right? Did we not do? Please help me understand. Did we not do logical reasoning?
We did.
We did, right? Okay. So that will be a part which is going to come. Many are logging in still. Mhm. Let's see. I really want to give you some introduction to proofs. You should be able to start writing proofs when you go inside. Conditional statements, I have gone over inductive reasoning, deductive reasoning, all that is important. But now I'm going to go ahead and give you some proofs. I have discussed converse, inverse, contrapositive, truth value, all that we have discussed. What I wanted to do was,
Miss Priya,
Dama,
it says it can't detect my camera. Is it fine if I like don't have it on until I can figure it out or
sure, ma.
okay.
Sure, but I want you to listen.
Okay.
Okay. Okay. I really want you to know a few postulates, okay? For you all to, 1 second guys, it's so noisy in here, hold on. Sorry guys, I didn't want the noise to be on you. So let's go ahead and see, postulates are just statements that I tell you and you accept it. That's it. Postulates are just statements which don't need proofs. They're just statements. When I say that, oh, you accept it. So I'll show you some examples of postulates. Without that, you cannot reason, meaning when you write proofs, right? Left side you have to write statement, right side reasoning, right? You will not be able to write the reasoning unless you understand what are postulates, meaning you should know enough postulates to write that as well, right? So my thought was to introduce you to a few postulates so that you have something in the brain to write out the reasoning. Make sense? So let me show you. How about this? We look over 7 postulates, okay? You'll have a good idea of what we are going to discuss, okay? This one is a 2-point postulate here. You can note this down if you want to. 2-point postulate. So what does it say? 2-point postulate says through any 2 points there exists exactly one line. Everybody will accept it, right? So A, B is the line. P, Q are the 2 points. Through points P and Q there can be only one line. More than one line is not possible. When I say that, you accept it, right? So that's a postulate. It's a 2-point postulate. Line point postulate. Line point postulate. Line point postulate says if there is a line, let's say we'll call this line PQ. We call this line PQ, definitely there are 2 points on it. You see, a line contains at least 2 points. It's a line point postulate. So basically these are just statements, very simple, okay? But then we sophisticatedly we say something big in geometry. That's it. So examples of postulates, one is 2-point postulate, second is line point postulate. What else? The third one, line intersection postulate. What is that? When there are 2 lines, right? And if they are intersecting, right, they will intersect exactly at one point. Basically, you'll all accept whatever I say here, right? When there are 2 lines, AB, CD, when they intersect at one point. Make sense? Okay. Now, the 4th one is quite important. The question, somewhere, sometime in geometry, whether it is in school or any other standardized test, right? Somewhere else they'll ask about this. Okay, but they may not ask, oh, what is this postulate or what is the postulate relating to non-collinear points in a plane? They won't ask you like that. But then, see, the postulate talks about non-collinear points and plane. Through any 3 non-collinear points, there can only be one plane. So a plane is always defined. How do you define a plane? It can have 3 non-collinear points. Through any 3 non-collinear points, there can be exactly one plane. It is quite important, and I have seen it come surface everywhere than the rest of the postulates. Okay, that's a 3-point postulate. Now, what is this? Plane point postulate. It's the same thing, meaning it's a similar, meaning these two are very similar, 4 and 5 are. A plane contains at least 3 non-collinear points. It's very important, guys. How do you define a plane in geometry? In a plane, there has to be at least 3 non-collinear points. So a plane is always defined by at least 3 non-collinear points. Then what is this? Plane line postulate. If 2 points lie on a plane, then the line containing them lies on a plane. If 2 points lie on a plane, then the line containing them lies on a plane. So these are just statements you're going to accept. Again, the last one, if 2 planes intersect, when there are 2 planes intersecting, right, what happens? The intersection is a line. When you think about it, when the 2 planes intersect, right, the intersection is a line. When 2 lines intersect, the intersection is a point. When these two are lines. This is a plane, then it is a line. The intersection point of two planes is a line. Make sense? See here, they're clearly given. Do you see here? What is the intersection point? This is the intersection point when you think about it. Any questions? These are examples of postulates. Why are we going through this? If it's just statements that you're going to accept, right? Why am I going through this? Because you should feel more confident to be able to write out some postulates as reasoning when we write proofs. Make sense? Okay, let's move on. Let's go ahead. 1 second. Okay, now what I wanted to do was I want you to do 1 or 2 proofs before you go back to school, definitely. Interpreting a diagram, I want you to be able to write a proof. Let's see. 1 second, guys. Okay. See, okay, yeah, let's do this one. Okay, I'll give you this equation. Shall we write proofs? We have done this earlier, right, guys? Have we done this or no? Yes, no, please tell me, guys. Meaning, if I give you, this is what is given. Okay, with this given, I want to find, basically, I have to prove, x value will be equal to -5. That's what I need to prove. X value is equal to -5. Have we done such proofs?
I think so.
Oh, we have not done, Amma. Shreya, we have not done?
No.
Oh, wow. 1 second, guys. Let me go back to your classroom. I am at a loss. How? 1 second, I'm going to check properly. For you, I have not done. Great. Give me a minute. How come? Okay, so basic proofs we have not done. So that's good. Okay, let's go over it now. Now, when you think about it, how do I prove it? Before I go into this, right? Then I need to go over algebraic properties of equality. Give me a minute, okay? I will discuss then in detail and then only we'll go to transformation. We don't need to go to transformation that quickly then. So I already told you postulates are statements which are just accepted as they are. So you need a lot of postulates when you write proofs. Okay. We have discussed conditional and converse, inverse, and biconditional as well, right? So now let's see. How about this? Before I go into some proofs, right, I really want you to be exposed to more postulates. Let's see. How about this? A line you are okay. Based on the past 7 postulates we studied, right? Based on the postulates, I would like you to determine whether the statements that I'm going to give you is always, sometimes, or never true. Let me see. I'm going to post some statements on the board. You're going to tell me, we went over 7 postulates, right? Based on those 7 postulates, you're going to tell me. I know I'm not getting in here because we have not studied something more in postulates. We'll come to that problem. Yeah. Here, based on the 7 postulates we studied, right? Can you tell me This statement, a line contains exactly 1 point. Is it always true? Is it sometimes true? Or is it never true?
Hello.
Go ahead, you can shout out.
Wait, Miss Priya, I just joined the class. Sorry for being late.
Yeah, I saw, Ma, no problem. You just concentrate. Let's move on. Okay, I saw that, and your dad did message me that you'll be late. That's fine. So go ahead and send in the answers based on the postulates we studied, right? A line exactly contains 1 point. Yes, Johan, that's right. We just need to be more aware of postulates, and that's why we are doing this exercise. Dhruv, it's not. Oh, yeah, Harshita, good job. Dhruv, the 7 postulates we studied, you weren't there, Dhruv. That is why you're not very sure about what we are doing. So I'm going to give you those 7 postulates. Since Dhruv is not there, I'm going to put it out on the board as well, okay, for him to deal with this. These are the 7 postulates we studied just now. Okay, so a line exactly contains, yes, 1 point is never true. Shreya, it's never true, Shreya. We studied, right? Remember, there are at least 2 points. See, postulate number 3, a line contains at least 2 points was there, right, Shreya?
Oh, I thought it meant like a line has like 1 point on it. Like,
No, no, no. If it, there has to be at least 2 points. So that's a postulate or statements that I say and we accept. Contains exactly 1 point. That postulate is never true. You got it? The statement is never true. Based on the postulate we studied. Which postulate was it? 2.3. When you look at the numbering I have given there, it's 2.3.
okay.
Now I'm going to, yeah, go ahead.
No, I just said okay.
Yeah. So let's go ahead and try 1 or 2 more, okay? I don't want this list of postulates to be in here. Then it breaks the purpose. Now, please, all of you try to answer. Planes R and S intersect in point T. Planes R and S intersect in point T. Go ahead. Good job, Abhyut. Johan, 2 planes intersect and what does it form?
Line.
So is it true?
No.
Two planes, see, 2 lines can only intersect at a point. 2 planes should intersect in a line. Harshita. Okay, let's go ahead and see this one. 2 planes are intersecting. Planes are flat surfaces, right? So see, when 2 planes intersect, when you think about it, it's a line, right? See, this one. Do you see what is the intersection of the 2 planes, right? This is the only intersection point for the planes that are intersecting. What are the intersection pieces? This is the only intersection piece and that's a line, right? Dhruv, am I clear? Dhruv Nayak.
Yes.
Okay, good. Okay, postulates, you need to be careful this, okay? Now, okay, how about this? I would like to give you 1 or 2. Let's see, wait. How about this? Did we discuss counterexample, guys? We did, right? Counterexample, conjecture. Conjecture is just a statement. But did we discuss counterexamples?
Yeah.
Okay, great. Now, let me give you a conjecture. Okay, this is a review of what we did earlier. I'm giving you a conjecture. Conjecture is just a statement. Each of you are going to message me, is the conjecture true or false? Is the conjecture true? Okay, let me put it out for you. Okay, is this conjecture true? Is this conjecture true? Is this conjecture true? Okay. If you say it is not true, if you say it is true, okay. But if not true, then find a counterexample. Find a counterexample. Mm-hmm. Okay. Dhruv, your answer is
Oh, wait,
correct.
I accidentally sent that. My bad.
No, Dhruv Nayak, your answer is correct, but the reasoning is incorrect. It says AB equal to BC, correct? AB equal to BC. So AB can't be 3, 4. See, the thing about postulate, counterexample, all these things is uh, even if your answer is right, okay, you can say, is this conjecture true? False or true, your answer may be right. But then, if you give a counterexample there, your counterexample should be correct as well. Counterexample means name one scenario where it will not be obeyed, the conjecture. Good job. That is right, Johan. What do you mean by that, Avyut? Yeah, no, Shreya.
I mean, line segment AB and line segment BC aren't connected.
Correct. So here AB equal to BC. If you think about it like this, yes, this is correct. But this conjecture need not be true. So is this conjecture true? False. Why? This is one scenario. But even if you find one scenario that does not obey this, then the conjecture, that's called the counterexample, and this is not true. Let's say A, B, B, C are like this. Let's say they are equal. The length of AB is equal to the length of BC. So still it's correct. Whatever this AB equal to BC, but B is not the midpoint. In this case, A, B, C are non-collinear. You have to become a geometry person. That's the problem with geometry. You have to become a geometry person speaking in geometry. So A, B, C are non-collinear is a counterexample for this one. Make sense? Shreya, did you get it, ma? Dhruv, you are also confused, right? Dhruv, Yerevar. You are also confused, right?
Okay, I understand.
But did you understand now?
Yeah, I understand.
Okay, good. Shreya, how about you, ma?
Yeah, I understood it.
Okay. How about this? Let me see. I think I'll give you a few more, guys. Yeah.
Miss Priya,
Yeah.
can you just explain like one more problem?
Yeah. In the similar to this, right?
Yeah.
Sure. Um, um, One second. I really want you to be able. Let me see. Okay. See, this is the proof I want to do, but before that, yeah, I want to define counter examples, right? Uh, okay, how about this? Okay. If angle 1 and 2, let me write it down for you. If angle 1 and 2 form a linear pair, then they are supplementary angles. Form a linear pair, then they are supplementary angles. How about this, guys? If angle 1 and angle 2 form a linear pair, then they are supplementary angles. What do you think about it? Dhruv, wherever. Please analyze the hypothesis. If angle 1 and 2 form a linear pair, that means what?
Like both of their angles add up. Like
Bottom up, please, it's okay to go wrong, right, Dhruv? Go ahead. What is
like
that?
for example, if angle 1 and 2 form a linear pair, then they're supplementary angles, meaning that if both angles are added up together, they would equal 180.
Leave all that. I'm just asking if angle 1 and angle 2 form a linear pair means how would they be positioned? Correct, Harshita and Johan.
Like right next to each other, I think. No,
What is it now?
right next to each other.
Form a linear pair means they are on a line. That's all. Form a linear pair means they are on a line. So I have to make angle 1 and angle 2 lines. Anyway, it has to be on a line. That's my only constraint.
So it has to be like that.
Because see, angle 1 and 2 together they form a linear pair means they have to stand on a line.
Oh, okay.
Then they are supplementary angles. Yes, this is true. There is no need to find counterexample. Make sense? Adira, did you go over this?
I don't remember going over like this kind of question.
No, we have not done this in class for that matter. I'm asking whether you did it in geometry at school.
No, yeah, that's what I'm saying. I don't remember going over like
Or
these.
these things. Okay, but you should know conditionals and all. Okay,
Okay.
just yeah. So let's go. Let's go through the next one. Okay. Now, guys, I really want you to be, it's more, not just postulates. Why are we learning postulates? As I said, we are going to write proofs. For us to write proofs, right, you should not only understand postulates, you also need to know more algebraic properties. You should also know more algebraic properties. Let me show you. What are these algebraic properties? Let me write it down one by one. I'm going to come to this, okay? Before I come to this, you need to know about postulates and algebraic properties of equality. Algebraic properties. What are these? Why are we going over it? There is a reason you're going to see now. Now, there is something, you all know this already. I'm just repeating for geometry, okay? Please, this is important. You have to note down, okay? Addition property of equality. What does it say? Let's say I'm telling, hey, letter A equal to letter B. If A is equal to B, then A plus C equal to B plus C. Do you all agree with this? You all know this already, but I'm putting sophisticated names to it and I'm working and I'm exposing you to that. That's all. Subtraction property of equality. What is that? Can one of you tell me what is that? Same pattern. If A equal to B, then who can tell me the subtraction property of equality? I told you what is addition property, right? So what is the subtraction property of equality? What do you do in addition property?
B minus C
Yes, A minus C equal to B
equals
minus.
B minus C.
Yeah. Now, what is this multiplication property of equality? What is this multiplication property of equality? Please, guys, one of you shout out, guys. See, what did you do for subtraction property? You subtracted C. What did you do for addition property? You added C on both sides. Multiplication property of equality means what? Tell me, guys. One of you should shout out. If you don't know as well, I need to know in messages.
You multiply.
Yep, AC equal to BC. Now, division property of equality says
You divide A and B by C.
Yep. Very nice. So you should know this. Why I am telling you should be able to use postulates and properties, algebraic properties in writing proofs. Now let me go ahead. It doesn't stop here. Okay. How about this? Do you know distributive property? What is this distributive property? I want you to know all these properties. Distributive property, you know this, we have studied earlier, but we are giving names to it nicely now. A times B plus C equal to AB plus AC. This is distributive property. Make sense? Distributive property over addition. That is distributive property. Now there's more to it. Okay. Other ones that we are going to learn are reflexive property, symmetric property, reflexive property, symmetric property, transitive property, and substitution property. Reflexive property, symmetric property. Let's see. Reflexive property. It's nothing but A is congruent, is A equal to A. A, the letter A is equal to A, right? Meaning it is equal to its own. Reflexive property. What else I said? Reflexive property, symmetric property I told you. That's pretty easy. As soon as I say, you'll understand. Symmetric property means if A equal to B, then what is symmetry? Left and right, right? B equal to A. That is symmetric property of equality. Shreya, are you following? Now, there's something called transitive property. Transition, making transitions. Transitive property of equality. You know what it says? If A is equal to B and B equal to C. One letter A equal to B. Different. Now, B is equal to C. Then what can I say? Then A is equal to C. Any questions? Transition. You're making a transition. A to B is there. Then you're making a transition from B to C. For B to C. So, transitive property of equality states that then A is equal to C. The last one, I forgot the last one. What did I want to say? Substitution property of equality. Substitution property of equality. See, there is a very subtle difference between transitive and substitution. If A is equal to B, then I can replace B for A. Wherever I have B, I can replace A. Make sense? Or replace A with B because we said A is equal to B. So you can replace A for B. You can just make replacements with two different letters. Okay. Are you all clear of those properties? Okay, now I'm going to delete everything on the board, thinking that you all have noted down. Can I erase?
Yeah.
Can I erase? Okay. Now let's
Priya,
yeah.
I couldn't read the last part.
The last part, it's nothing but substitution property, ma. A is equal to B. If I say that A is equal to B, then wherever you see A, you can plug in B.
Okay.
That is you're substituting, right?
Yeah.
One question I had, guys, before I move on. In the homework, right? For a few of you, I posted voice feedback, right? Did you get it or you didn't get it? I'm experimenting with a tool. Did you get it or you didn't get it? Particularly, I dropped voice messages for Avyuk, Dhruv and all. Did you get it or you didn't? Johan, Harshita, I dropped. Did you get those voice messages or not?
I'm gonna check.
Huh?
I'm going to check.
Oh, you want to check? Okay, you can check and let me know. But I'm just experimenting on something. I don't even understand whether it went to you or not. When I see my screen, it says that it recorded, but it never said that it went to you.
Where exactly are you expecting it?
Google Classroom.
Like on the class messages?
Yeah, for your assignments. If it's not working, it's okay, guys. I just want to know. If it didn't come, it didn't come. I have to work. Meaning, I'm missing something. I'm missing to understand the new extension. Extension or whatever, the tool that I used. It didn't come?
I don't think it came for me.
Okay, thanks. That's enough. That's fine. Let's move on. Now, what is this? What is this property? What is this algebraic property? If x is equal to 23.45, then 23.45 equal to x. One of you please shout
Is
out.
it transitive?
Is it symmetric?
It is symmetric. Okay, let me show you the difference. See, when I say A equal to B, B is equal to A, do you see symmetry? Left equal to right, right equal to left. That is why it's symmetric. Whereas transitive says A equal to B and you're transitioning B equal to C, then A equal to C. Makes sense? This is transitive property of equality.
Okay.
Now I want somebody else to answer if that's okay. How about this? What property is this? I don't want you to pick you guys, but I want you to make mistakes and learn. If x is equal to y, then 8x equal to 8y. What is that?
Is it multiplication?
Yep, Ananya. Thank you, Ananya. Nice. See, that makes me feel, oh yeah, they're listening. You see? Okay, now let's see this one. Yeah, this one. Yeah, anybody else take a turn? How about this? If you want, you can send it to me in chat as well. If you've already answered and you're waiting to answer, please send it in chat. Anybody else can try this one? Oh, you didn't get it, Harshita. Thanks. I'll check. Come on.
Which one is Priya? I can't see it on the board.
Really sorry. Wait. There is only one problem on the board, right? What is this property of equality? What is this algebra? Oh, you want me to write it down maybe? If x equal to 12, then x minus 3 equal to 9. How about that?
Is it? Can I say it or I don't know? Or
What, Amma? What was that, Shreya?
like, should I say it in the chat or?
You can shout out. It's okay.
I think it's subtractive.
Subtraction property of equality. You subtracted 3 on both sides. Good job. One last one maybe. How about this? Okay. It's an easy one. You have studied this all along. How about that? Anybody else who has not answered, please try this.
Distributive property.
Distributive property, yeah. Distributive property. There is no, yeah, distributive property over addition. Okay, I think we are good, okay, with whatever postulate. Okay, and then there are two more postulates that I want to talk about to you. Yeah, segment addition postulates and angle addition postulate. Segment addition postulate, it might be a whole lot, it looks like, but it is not a whole lot. Postulate are just statements. Segment addition postulate and angle addition postulate, these two are important postulates you need to know, because see, without this we cannot do any proof, we cannot even write proofs, it's not worth it. So better we learn this. Let's say there is a line segment AB with a point C between it. You see here, AC plus CB, AC plus CB equal to AB. Any questions? Segment, this is a line segment, this is a line segment. You are adding them. Segment addition postulate. Did you get it? How about this? What is this then? Who can tell me about this? Who can tell me this?
Angle 1 plus 2a
Angle,
the
yeah,
whole angle. So it's the angle addition.
yeah, this is angle addition. So here, angle ACB, measure of angle ACB, measure of angle ACB will be equal to measure of angle 1 plus measure of angle 2. That means angles are being added, angle addition postulate. Okay, for now, I think this is enough. Let's move on. Let me show you some proofs. How about this? I asked you to do that, right? I'm going to start writing proofs for you. Okay. Why are we going to write proofs? We talked about logical reasoning. We talked about logical reasoning. We talked about inductive reasoning and deductive reasoning. You all remember, right? So basically, a step by step, meaning it's a group of steps, okay, that we are going to write. We are going to solve problems using that group of algebraic steps. Okay, this structure, whatever steps we are going to write to solve a problem, right? It's basically a deduction, meaning from line number 1 I get line number 2, from line number 2 I get line number 3. It's a logical sequence of statements. You don't have to be a geometry person, you can be a layman. A layman, when he reads that, he'll be able to understand how statement 2 came from statement 1, how statement 3 came from statement 2. So it's just a logical sequence of statements which you write it in 2 columns. That is a proof, meaning it's a 2-column proof. Let me show you. First, let me show you what I want to prove. See, a 2-column proof is written in 2 columns. The left column is statement, right column is reasoning. But what are we going to prove? One example of what we are going to prove. I gave you an algebraic proof, right? Remember? Let me show you. Let's say this is given. Always see, proofs will have something given and something to prove. Given and to prove. They'll give you this. Okay. Yeah. So this is what is given. This is given. Okay. I have to prove x equal to 4. Any questions, guys? I'm going to show you how I'm going to prove. Before you go to school, I want you to really get it. And each of you should shout out the logical sequence of statements for me. First one, I'm going to do it for you. Okay. Statement. I'm going to write a 2-column proof. Split it out into 2 columns. Statement, reason. Always this is the structure. Okay. The first statement, the very first statement is the given statement. 6x plus 2 times x minus 1 equal to 30. Given. What can be the next step? From this step, how can I use my postulates? How can I use my algebraic properties to write out the next step? The ending, what I need to arrive is x equal to 4. What is the next step I can do? How to solve for x, guys? Just an equation, right?
Can we use distributive property of equality?
Yes. So I write this down, meaning I distribute it and say, the reason you have to say why I'm writing this. Distributive property of equality. Make sense? Now, what is the next one?
Add
Mm-mm.
like
No, we'll do one thing. We'll do one thing. Can I add 2 to both sides? What is a property?
Additive property.
Hmm?
Addition property.
Addition property of equality. See, this is why we learned those proof. See, postulates we'll use next. Okay, this is an example of algebraic proof. Addition property of equality. And then what? Now you just simplify. Okay, 8x equal to 32. Simplify. Simplification. And then what is the last one? Who can tell me the last one?
Division.
Yeah, division
Property.
equality. Correct. Make sense? This is how you write proofs. Particularly, this is called an algebraic proof. Algebraic proofs, and this is called a two-column proof. Okay. See, the thing is, when you come to the types of proofs, right, in geometry, what are all the proofs you're going to write? The first one everybody writes is a two-column proof in two columns. Okay. Another one is the same thing, you can write it into a paragraph. It's called a paragraph proof. Or if you use a flowchart and write proofs, it's called a flowchart proof. There are three types of proofs. Okay, in geometry, you will be exposed to all the three. One is a two-column proof. The same two-column proof, you just write it into a paragraph, it becomes a paragraph proof. And if you draw flowcharts, then it becomes a flowchart. Any questions? Flowchart means it will have the start, end, all this stuff, right? So like that in boxes, if you start writing the sentence, the statement and the reason, all the proofs should have statement and a reason, statement and a reason, statement and a reason. Okay, for now we'll just do two-column proofs. Make sense? Let's see, how about this? Let's see. I just want to do one more. Okay. Now, let's do one more. You do by yourself. If you don't know, ask. I feel like it. Okay. How about this one? How about this? Yeah. This is an easy one, guys. Come on, you're going to say by yourself. This is an easy one, just for you to get a hang of it. Who wants to try? Anybody can try. Duru, Nayak, can you try?
On the board.
Yeah, you can. I'll write it for you. The first statement is always given. Then what?
Then you have to multiply by 3
Good one.
on both sides.
Good one. So what is that property? This is given. What is that property? Then you'll apply.
Multiplication.
How will you? You cannot just like that. You have to be picture perfect with the words that you write. Multiplicative property. Multiplicative property of equality.
Wouldn't it be multiplication?
Multiplication property. Yeah. Okay. Whatever we said. I'm sorry. Good job. Good job correcting me. Multiplicative property of equality. So if you multiply 3 with 3 on both sides, it becomes y plus 2 y plus 2 will be equal to 9. Next, what should I do? Let me write it down properly because this is the first time I'm writing. You should not get confused. Y plus 2 equal to 9. Go ahead. What next?
You subtract 2 on both sides, so it's subtractive property.
Subtraction property of equality will be y equal to 7. That's it. This is a two-column proof. Now, you can solve many of these in homework, okay? But before I go into more proofs, there are more things that I want you to know. In the sense, you should know some properties and definitions. You should know some properties and definitions. There's a ton of them. I'm going to go over them one by one. Okay? Let's see. Let's see one by one, okay? I'm going to take this up. I'm going to write out something. This is quite important, guys. A lot of definitions are going to be useful when you write the two-column proof, statement, and reasoning. Okay. So you should all keep this in mind. Okay. Let's see. We are going to write out some definitions. Okay. Which we will use for our proofs. Okay, without a knowledge of these, you can't write proofs at all. Writing proofs is such an important aspect in geometry. We are going to go over a lot of properties and definitions. Okay. Now, let's say, if I say, if I'm going to say ABC is a right angle, then what can you say about ABC? Who can tell me? Measure of ABC is what?
90 degrees.
Yeah. You know, here I would say, see, if there is a place where I see ABC is a right angle, I can come to the conclusion that the measure is 90 degree. This, is useful when you write a, a reason statement. In the right side of two column proofs, we are writing reasons, right? There we'll usually write, if this happens, right, we write it as definition of right angles. Right angles define that ABC, if ABC is right angle, then ABC is 90 degrees. Now, let's say if points CDE are points on a straight line, if they are points on a straight line, then what does it mean? Then what can it mean? If CDE, or if CDE is a straight angle, if CDE is a straight angle, let's say, if CDE form a straight angle, then what does it mean? Measure of CD is what?
180 degrees.
Yeah, 180 degrees. So that is called definition of straight angles. We will use these reasoning. This particular column alone you'll use in two column proofs for the right side. That is called, you will write the reasoning as definition of straight angles. So many definitions can be used to write out the reasoning in proofs. Then the next one, if I say, hey, angle 1 and 2 are complementary angles, what does it mean? Angle 1 and angle 2 are complementary angles. What does it mean? What does it mean? You all know, right?
180.
இல்லம்மா, complementary ma? Complementary means 90.
90.
Yeah, supplementary means 180.
Oh, sorry.
No problem. This is called the definition of complementary angles. Any questions? Any questions still here?
No.
Okay, great. Then let me go ahead and ask you this. Let's say 3 and 4 are supplementary angles. What can I say about their measures? Oh, 3, yeah. What can I say about their measures?
They equal 180 degrees.
Yep, what can it be? Meaning, how can I write the reason?
Definition of supplementary.
Supplementary angles. So the thing is, I always see every year when geometry starts with proofs, right? When we start proofs in geometry, right? Kids just fall off the boat. They find it very difficult to write reasoning. That's why I thought we'll first introduce yourself to a lot of postulates that you will write in reasoning, or the properties of algebra, or these reasons fall into the reasoning space in a two column proof. Okay, if you can remember all these, then it's easy to write a two column proof as well. Okay, now let's say, how about this? Okay, let's say AB is congruent to CD. AB is congruent to CD. If AB line segment is congruent to CD, then I can say this is the symbol for congruence. Congruence means same shape, same size. Similar means different shape, same shape, different size. Congruent means you have heard of congruence earlier, but you don't know the symbol. This is the symbol of congruence. This says line segment AB. You have to be a geometry person reading it in geometry. How do I read this? Line segment AB congruent to line segment CD. Then in that case, I can say AB equal to CD. Why?
So I'm in the class.
Definition of congruent angles. You're okay, Dhruv? Now let's say angle ABC
Did
is
you call
congruent to angle DEF. If I say that, then what can I say? Measure of angle ABC is equal to measure of DEF. What is that? Definition of, I'm sorry, this is congruent segments. Guys, we are talking about line segments in the first statement. This is a line segment. Whereas angles means like this, right? A, B, C. 3 letters are used to denote an angle. 2 letters are used to denote a line segment or a ray or a line. 2 angles are equal, right? D, E, F and A, B, C. In this case, they are congruent. Means this is called the definition of congruent angles. Any questions, guys, still here? I know I'm putting a ton, but these are just postulates, right? It will go in automatically. But do you have any questions? I'm here to answer. We have a lot more. I'm going to cover all of this. Can I go ahead? I'll give you notes on this. Okay. Let me see this one. Okay, let's see this one. M is the midpoint of AB. If M is the midpoint of AB, M is the midpoint of AB, that means what? AM line segment is congruent to MB. Any questions, guys? This, you can call it as the midpoint theorem. Theorem requires proof. All these are postulates that you accept. Now, M is a midpoint, and then what else you can say about, see, if I give you a line like this and mark it like this, if I mark it like this, I can literally say, I can say AM. See, the length of line segment AM is equal to the length of line segment MB. See, there is a difference. This is congruence. This is equal to sign. The length of AM is equal to the length of MB. That is definition of midpoint.
Wait, I have a question. When you do the congruent and equal, don't they both mean they're just the same?
Yes, technically yes, but congruent says a lot more than just equal. You see what I mean? Meaning congruent means in all aspects, not just the length, much more to it. In all aspects, AM is the same as MB.
Okay, and AM equals MB is just for the length.
Length, yes.
Okay.
But good question. Can I move on?
Yeah.
Okay. Can I erase?
Yeah.
Okay. Please, guys, I'm going to cover a little more. Okay. I know that's going to be boring, but this is going to be so important to write out the proofs.
Miss Priya,
Let me finish. I have 9 more to go. Go ahead.
I have to go right now.
Oh, okay. No problem. Okay.
I'll look at the recording later.
Sure. Let me finish quickly. Okay, how about this? A, B, C are collinear. If I say, I'm going to write it down quickly for you, okay? If, then, reason. If A, B, C are collinear and B is in between A and C. AB is congruent to BC. Any questions? Any questions on this? What is this? What is this postulate? What is this postulate? And wait. I want to do this. And AB. Okay, first of all, B is in between. No, they're not congruent. Wait, guys. If ABC are collinear, let me draw it and see. ABC are collinear and B is in between AC. Then I can write AB plus BC. See, the line on top is required. You're a geometry person. Equal to AC. What is this postulate? What is this postulate?
Segment addition.
Segment addition postulate. You're adding segments, right? Segment addition postulate. Then the next one automatically comes. See, let's say ray R is interior to QS. Ray R, OR is interior to QOS. Then I can say measure of QOR, which is this, plus measure of ROS. You see, ROS will be equal to measure of QOS angle. What is that? Angle addition postulate. I don't mind continuing later too. It's a lot. Okay. How about this? I'll stop here. One and let's say here with this I'll stop. How about this? Angle 1, angle 2. When I see this diagram, I can say 1 and 2 form linear pair. Right? I can say 1 and 2 form linear pair, right? So that's what I see. So what can I conclude? See, clearly here 1 and 2 form linear pair. So under then what can I write about it? If 1 and 2 form a linear pair, then measure of angle 1 plus measure of angle 2 is 180 degrees. What is this? Definition of definition of
Complementary.
complementary or supplementary, Amma? Complementary or
Supplementary.
okay. Okay, I'll stop here. So there is more like this. There are more definition that you might want to do, but I'll give you a simpler homework for this week. Maybe I'll give you a simpler homework. We'll continue with all these definitions, finish up the definitions, then we'll do one more homework on that. Make sense? Make sense? Or I can give you this as the homework and you can look through the last three definitions. Definition of right angles, definition of right angles. So, okay, I really want to go over the last 6 by myself. I don't want you to go over, so I'm going to limit the homework. Just part 1 and 2 you can do and come. After I finish the last 6 definitions, you can do part 3 of the homework. Any questions? Any questions? Hey, any questions, guys? Yes, no, there are 2 answers, right? I need to go too. Any questions? Okay.
No.
Okay, guys. So we will do just part 1 and 2 in the assignment that I'm going to post in Google Classroom. Okay. Okay, guys. If you don't have any questions, we continue our fall classes right from next week. Okay. Similar times only, but please, I'll send welcome emails. Make sure you get them from your parents. Check the times and then log in on time. We'll just continue the fall classes as is. Okay. Okay, guys. See you all next week. If you have questions, stay.
Bye, Miss Priya.
Bye.
Yeah, ma. Bye, ma. Bye, ma.
Miss Priya.
Yes.
So when I completed geometry,
One
I
minute. 1
yeah.
minute. I'm going to stop the recording.
Okay.